Hello, it's Duncan. My regular viewer will know that I'm a test-driven fanatic. I love to find new ways to make tests more expressive and economic, so I was excited when I saw there was a lightning talk at Kotlin.conf on Power-assert. Power-assert is a compiler plugin that enhances the regular Kotlin assert function. It promises to help us understand why a test failed without needing complex assertion libraries. As a developer with a bit of a complex assertion library habit, this is intriguing, so please join me as I convert some tests from plain old JUnit and the Strikt assertion library to see if Power-assert is testing methadone.
I'm a teapot. Well, here we are back in Gilded Rose after quite a while, and after all the trouble I've had with Gradle recently, I should say that upgrading Kotlin from version 1.9.2 to version 2, released at Kotlin.conf, hooray, was entirely painless, so it's not all bad. But we're not here to talk about Gradle, we're here to talk about testing, and in particular to look at Power-assert. In order to do so, I'm going to look at ListStockTests. Here it is, and you can see, if we ignore some gubbins at the top, that we create a price stock list, we run up the app with that stock list, and then we check two things. We check that if we ask the app directly to load the stock list, then we get what we expected back. And also if we make a GET request to the root, that we get a rendering of that stock list with this app expected rendering for. There's that test. There's another one that fakes out items here in order to show that we report errors. Not really interested in that. And that's it. Okay. So let's fold that one away and go and have a look at what we have here. And in particular, we're interested not in the way that we run tests, but in the ways that we make assertions and the ways that failures in those assertions are reported. So the first assertion we have is this assert equals here. Let's have a look where that comes from. And the answer is it's assertions.java inside JUnit. Now, in fact, I don't think I really should be using that. Let's just see why. If I go back here, you see that I'm checking that the app's load stock list is equal to expected stock list. But in fact, because this is JUnit, I could put in anything in here and that would still compile. Now, that's a problem with Java that Kotlin can solve. So if we were to go up here and instead of importing, where is it, JUnit assertions assert equals, if we took that out, go and fix the issue and say instead we want the version from Kotlin.test here, you notice that's parameterized with a T. So if we do this, then you'll see that now we couldn't make that test. We can only specify two types that are compatible with each other. So that allows us to restore this, and inside you'll see that this talks to an asserter, and that eventually will just talk to JUnit. So we're running the same code, but we're a bit more type safe. And we are actually running tests today, so let's go up here and we'll just say run all these tests. Good. Okay then, so everything passes. Let's have a look at what happens when it doesn't. So I think what we'll do is we'll just map this to change the thing inside the success, and we'll say it dot, and we will drop the first item from it, and let's run that. Oh, I see the problem. We need to say it dot copy with the items is it dot items drop 1. Okay, let's run it. And it failed, and let's have a look at what we get. So we get expected success of price stock list with some items in it, and we get a click to see the difference, which these days actually highlights somewhere in here, yes, like that, where there are diffs, but it's a bit unfriendly because it's all on one line. But we can only see that we're missing an item. Okay, I'm just going to go and have a look at this assert equals again. Here it is. And you can see that it's one of a family of lots and lots of different assertions. We've got assert equals t's and doubles, because doubles have tolerances, and assert not equals, and goodness me, well, assert false, assert true, assert same, not same, assert is, and assert is of type. A whole bunch of different operations. Fundamentally, they all kind of map back to assert true, pull that in, that thing equals that thing. And if I run that, then it fails as we expect. But the problem now is that all the test runner knows is that this was false. It doesn't know you expected this to be equal to this, because it can't look at this equal sign and decide that's what you're doing. So that's the reason for all of these JUnit methods, things like assert equals, that it allows a decent error message because we know that we expected them to be true, but for example, assert not equals, that would pass now, Oh, well, it doesn't, but only because later on here we've changed our expected price stock list. So maybe let's just go and fix that up. We'll have duplicate that. We'll call this one not expected price stock list, which is that one. The expected price stock list is that one, and then we can say, let's just go and fix that up. So we've got both lying around. This is going to be expected price stock list. And so if we now put not expected in here, that passes as we expect. But if we used expected price stock list, that I seem to have renamed badly, in here, then the framework knows that I expected them not to be equal, so it can give a different error message. There we are, expected not equals was something. Okay, let's just return this to what we expect, which is expect equals expected price stock list to be that. And I think a better phrase would be unexpected, and run. Good. By the way, if you want to know where that test runner comes from, it's courtesy of my friend Dmitry Kadylov, and I will post details in the show notes below. So, when we're making assertions, we have to choose which assert we want to use in order to get decent diagnostics out of it. But what if that wasn't true? What if we could just say assert, which is actually a Kotlin built-in thing, there you are, that equals that. Well, we know that that will pass when it's true, and it will fail when it's not true, and that we will get very little information out of that. But what if we could get more information out of that? Both Python and Groovy have a way of extending the assert to look inside here and make sense of it. Could we do that in Kotlin? Well, not with the language as it is, but if we don't like the language as it is possible to change it with a compiler plugin. And that's what we have now in Power-assert. So, Power-assert was written by Brian Norman. Here it is on GitHub. And I've known about it for a while, but the thing that's put me off is the compiler plugin and the fact that down here we have to manage Kotlin versions and plugin versions and so on. And frankly, I wasn't sure that Brian could keep up with changes to the Kotlin compiler. However, it turns out that Brian Norman now, or maybe always, worked for JetBrains. And so the Power-assert plugin has now been brought into the standard set of plugins available with Kotlin. It's experimental, but with this information I think it's a lot easier to take a punt on. So let's see how we install it. The answer is we add Power-assert to our build. Let's copy that. And before we go on, we'll just have a look. It says configure the plugin. It will by default change Kotlin assert calls and work with test source sets. Well, that will do us for now. So back to our project. And in our build.gradle, we'll go back up to the top and add the Power-assert plugin. You saw down there that things happened, so I think it's probably installed. Let's run the test again. It failed as we expected. Let's see what we have. So now, instead of just assertion failed, we have assertion failed and a diagnostic of what was going on when it did. So you can see it's broken this statement down, and it's told us what our unexpected price stock list was. There it is. It's told us that the test turned out to be false. It's told us that the app was, well, this app here with some in-memory items and so on and so on. And then the call to load stock list resulted in success of a price stock list that we know won't be the same as this one. Now then, compared to the assert equals, this is both better and worse. It's better because we showed the context around us. We showed what the value of app is in here. We've shown some other parameters that I don't fully understand. We showed the actual, this one, and the expected, this one, but we're not showing them in a way that we can compare easily. If you remember when we changed this to be assert equals, then we got less information about the context. We never found out what app was, but we could at least click on here and see what the diff was. In return for losing that diff, we can pretty much always just use assert. So we don't have to decide that we're using assert equals or not equals or whatever. If we want to use not equal in here, we can say not equal to, and then we could say expected is not equal to that. Get rid of that one. And if I run this, you'll see that we get a very similar trace as before. The not equals is false, and we've got all the information about the two sides of the comparison. We could also use something like expected stock list dot value dot items dot size is greater than load stock list value or null items size, and then we would get information about the sizes put in there. You can see each part of this expression we're being told its value. I'm not entirely sure why we're not seeing the value of these intermediates here. I wonder if I change this and make this result of a success of price stock list. I could make that happen by moving this price stock list into here. So I could say that this is price stock list, and then I wrap that in a success. Make this price stock list items. Now I shouldn't need to do value. Oh, but I haven't actually changed this side here. App load stock list. Yep, don't really understand that. I'll try another trick, which is to say that this is a variable. Pull it out of here so we can see it. We're not really interested in the app inside this assertion. So I think we could say this is value or null, and we know that isn't the case. And now this would be value items size. That can go. Does that give us better? Yes, it does. Interesting. So now we're seeing the value or null, which isn't the value, it is the value from app. And now here it's drilling down through the price stock list to the items to the size. And when I say drilling down, I think I mean drilling up, but you get the gist. Just out of interest, I wonder what happens if I replace this with a function call and run that. And there you go. You see, we don't have to use operators. We can use any expression that evaluates to boolean inside here. So I think we can predict that the compiler plugin is having to remember this entire expression when the code is compiled. And then if this works out to be false, evaluate the individual parts of it and make that into a nice message like this. Okay, I'll return this to what we really want, which is the expected stock list value equals the value from app. And then I can inline that, removing that. Oh, but that needs to be an equals. Good. So an interesting side effect of this is that we get out information according to what's inside these brackets. So again, if I was to pull this out as a variable and call it loaded stock list and return this to unexpected, then if I run this, I just see this as its value. Whereas if I inline this and run, then I see the value of the app and the result of running load stock list on it. So we can tune our output by what we include inside the function call. And I suppose if we want to express the fact that we're only loading the stock list in order to check it, we could pull this out as a variable, and then we could do the .let trick of moving into there like that, and then move this up into here, and then remove that, and then make that an it. And IntelliJ is saying, oh, it could remove the let vocal for us. Well, thank you, but that was kind of the point. But I don't want to give you that, so let's go back to that version, which I think is clear enough. Okay then, what about the second test down here? This is using Strikt, which I covered in the previous episode. And with Strikt, we start with the subject. So we say that expect that subject, and then we can have matches on that subject. This status is from an HTTP extension to Strikt, and the same with body string. So it's a nice fluent expression, and we can always inline this into here, and things are still the same. Okay, but the question is, why are we doing that? Why aren't we just saying, I'm going to do it in old terms, so we're going to say assert equals, well, our actual is going to be this request route, this thing here. And our expected, well, we could just build a response, because responses are just objects in HTTP. So we should just be able to say response with the status of OK and with a body of the expected rendering for the expected stock list. So like that. And before I run that, the way that you'd express that thing in Strikt would be to say that we'll take that thing, we'll expect that app roots dot is equal to a response that looks like that. So that would be the Strikt equivalent of assert equals. Well, let's run them and find out why we did this instead of this. And here we are, failure. And we've got a nice diff, so let's use it. And the left thing is what we expected and the right thing is what we got. And you can see that on the right we have some extra HTTP headers. In this case, the content type that was added by HTTP and some trace IDs. Now the content type we could have set into here easily enough, but these trace IDs are randomly generated by our app, and randomly generated is kind of the point. I suppose we could faff around with mock UUID generators or that sort of thing, but that's a complication we really don't need. So we either check just the bits of request that we want, or I suppose that we could say here that we would take our response and remove all the headers. And if I take that one away, because we don't really need it, I think that might make it pass. And does. So we have two ways of making assertions on only part of structured data. One is to select the bits we are interested in, and one is to unselect the bits that we aren't interested in. And Strikt is very good for selecting the bits we're interested in, because in here we had the global object here, and then we're picking bits out of it. And in fact, we need not have been using HTTP4K's versions. We could in here have said get status like that, which would have been the equivalent. Okay, let's see what happens when these fail. So let's take the unexpected price stock list and expect the rendering of that and run. Okay, so this is the test that's failed. Let's have a look, see what we've got. So we've got an assertion failed error, click to see the difference, and oh, that's really rather nice. We can see directly the response that was different. If we go up to the top, you can see that we had the whole HTTP response and neither have headers because we took them out of the response from the app. So that's really nice. Let's see how Strikt does. We will swap these over. So we'll make this unexpected and this one, no, the other way around, run. And again, we've got a failure as we expect. And, okay, scrolling to the top. Strikt, when it fails, describes the expect that. So it says expect that this thing, which is our entire HTTP response, including the trace IDs because they were there, we didn't take them out. Lots of gubbins, and this is that unfolded. And then cross for not is equal to this thing. So this is the version without the headers. And then found, well, it seems to be repeating itself a bit, but we'll let it off. And then it says it again, I'm not quite sure why, expect that. And it shows you what passed and failed. So it shows you that the value of the property status was equal to 200 OK. And then down here, that thing, which is the body, was not equal to that thing. So it's able to make a description of this entire block here and tell us which bits passed and which bits failed. That's very nice, and it's the reason that we like Strikt. But note, compared to this assertEquals, if we wanted to get into why the body strings were different, we'd be copying and pasting into buffers and comparing them and so on. Let's let Power-assert have a go at this first one. So we'll take that, put it in here. We just need to change this to equals equals, and we want to make it fail, so we'll say unexpected price stock list. I'm going to make that back again before I forget and run that. Failure as expected. Let's have a look. We'll go all the way to the top and we'll make this as big as we can. Okay, I think I've made things harder for it by splitting it into more than one line, so let's stop doing that. Go back. That's the one that wants to be on one line. Let's do that and run. And go back up to the top. Ah, there we are. Well, I imagine that if you trace some of these down, you would see them all the way down here somewhere. Yes, there you are. You can see, I think, the values of these things coming out against the pipe character that lines up at the top. So again, we're getting the values of all these expressions, but unfortunately they're multi-line strings, and as with Strikt, actually, it's not coping all that well. So let's cast this a bit more like the Strikt version. Instead of removing the headers and testing one big thing, we're going to test the individual bits. So let's pull them apart. Let's say this is a variable for our expected rendering. We'll just do this one, we'll call it actual rendering. And actually I think that isn't the actual rendering, that's the response. Now then, let's make two assertions. We'll assert that OK equals the response.status. And we'll assert that the expected rendering is the response.bodyString. And we're still using the unexpected one, so one of these we expect to fail. Let's have a look. Okay, back to the top and see what it says. And here you can see we're just looking at big multi-line strings, where I think we know that assertEquals would have been better. But again, should it come in handy, because the response is in here, not just the body string, we are going to see a rendering of the whole response and then a rendering of the body string. Now what we might want to do instead is say, well look, this is just a boolean, let's take this and we could say that equals that and that equals that. So I can get rid of that and run. Now you can see right down here we're showing the results of this OK equals response status here is true here, and no doubt there'll be a rendering of all this up the top. Goodness me, yes, but you see we're seeing all the bits of it. However, I think there is an issue, which is if we said we wanted I'm a teapot and try running that, that fails as we expect with I'm a teapot is false compared to the status. But note that we haven't got any pipes under this bit, so we're not seeing what the expected rendering is or the response here. Well, we see the response here because it's the same response, but we can't see what the value of response.bodyString is. And that's because short-circuiting this AND means that this second bit here was never evaluated. So compared to the strict version that would have shown us this even if this has failed, we're not seeing the second part of this expression. Now, Power-assert has a suggestion for that, which is soft assertions. Let's go and have a look. So the idea here is that inside this assert softly, it will collect errors and only report them at the end. So let's copy that, add it to this file here. Now, unfortunately, we now need to configure Power-assert to know about this because it's in our code base and not shared anywhere else at the moment. So the package here is com-gilded-rose, and it's this assert softly. Let's go back. Now we need to configure the plugin. Let's take this, which is Kotlin.test, never mind. Back to our build.gradle, down the bottom, paste that. I think we might get away with just saying that is Power-assert, and then this is a groovy array. And now this is saying I want you to enhance the Kotlin assert, which is one we're already doing, the Kotlin.test assert, which we haven't been using, but also this would be our version, which is com.gilded-rose. Okay, back here, armed with this, let's use assert softly. So now in here, we can say get that and then assert softly some things. Assert, and now this version maps to this one, which is implemented as this one. So back here, so now we can say assert that and assert not softly, expected rendering is body string, that thing. So let's take that and run. See what we have, scroll all the way to the top, assertion failed, I'm a teapot is response.status. So what are we seeing? We're seeing, well, this response is now our entire response. So we're seeing all of that a little bit tediously, although that might come in handy. But no, we're not actually seeing anything about this one here at all because it didn't fail. So again, I think probably we don't really want to see this entire response. Maybe we do, maybe we don't. But we might say response.status.let assert I'm a teapot equals it. And then when we ran this, we would see only the bits we were interested in. Yes, and we are in fact failing the second bit because we're saying the unexpected price stock list. So now we're seeing the second failure as well, and we're seeing the amalgamation of those two failures. We're not just stopping when this one fails. If it didn't fail though, and we made this expected price stock list, then the first one would fail, the second one wouldn't fail, but we wouldn't hear anything about the second one at all. Very, very simple, compared to the strict version here, where it will actually tell us what the body string is, even if it's only the status that fails. So, horses for courses. I'm just going to return this to OK, so that everything is all right. And then finally, it's a bit irritating that we have to configure Power-assert to use assert softly, but I think there's an alternative. So I'm going to take this out of here, because JUnit actually has a way of collecting multiple failures. So instead of this assert softly, we could say assertAll. And you can see there's a set of overrides here. Fundamentally, the one we want is this one here that takes a vararg of executables, which are unit to unit. So let's import that. And now we can give a set of lambdas that are the assertions. And now if we undo this and move this one into here and move this one, well, copy I suppose, into here. Now we were passing and we'll continue to pass. But if we change this one to be I'm a teapot and run, let's have a look at the output now. Okay, back up to the top. We're still getting the output from Power-assert, so assert I'm a teapot is response status. We're still drilling down now into the response, that's this one here, so we're seeing the entire response courtesy of Power-assert. And JUnit is marshalling these things into a multiple failures error where there's one failure. So this is the report of the multiple failures error. If we fail twice, then we could say this would be unexpected price stock list. So I could now take this and put that into there. If I run that, then we should get a multiple failures with 2 failures in it. Here we go, multiple failures error, multiple failures, 2 failures. So it's reporting the first one here and the second one, I'm sure, somewhere else. For some reason, JUnit seems to show the failures twice. So we're seeing the 2 individual failures and then the multiple failures, which is then rendered as the 2 individual failures. Go figure. So this assertAll can allow us to collect together a number of failures with Power-assert reporting, but doesn't do the nice Strikt thing of showing you things that passed as well as the things that failed. Also, what we don't have is this idea of Strikt to the subject, but we can solve that problem. I'm just going to take this away, I think, for now, so we can come down here and see. Let's get rid of that and all its little wizards. And now what I'd like to be able to say, I'd like a function that for some t was assertAll, taking subject, which is a t, and a vararg set of assertions, each of which took t as the receiver, and returned unit because they'll throw if something goes bad. And we'll call these checks. And how could we implement that? Well, we can say assertAll. There's a version of this that takes a string that describes it. So we're going to say for $subject. And now we need to map these checks into lambdas. So that is checks map. And then we can take the lambda and apply it to the subject. And then I think if we map that to org.JUnit.jupyter.api.assertAll, some sort of issue. Let's find out what the type of that is. It's a list of unit. What we actually need in here is a lambda inside the lambda. That will now not be list of unit, but list of function that takes nothing and returns unit. So now we can inline that. Now we can say I'm asserting all on the response, and these lambdas will have the response as their subject. So we can get rid of that, and we can get rid of that. We'll return this to expected price stock list so that we can see how that does, and let's run that. Back up to the top, and now if we find the multiple failures error, here it is. So it's saying for HTTP OK. It's now listing the entire response, which is the subject. Well, I suppose we asked for it, so we got it. And then it's saying there's one failure, it's assertion failure, which is I'm a teapot is not equal to status. And I think because it's the receiver of status, we're seeing not only the 200 OK, but we're seeing the entire receiver here, so that we can see the subject all over again for our delectation and delight. I suspect that would all be tidied up quite a bit if I just put that in there, and then we're just going to return this to OK so that everyone is happy. Hooray! So, which assertions library should you use? In this project we have, looking down here it turns out, assert that from Hamcrest. We have JUnit assertions, we have Kotlin.test assertions, we have Strikt assertions, and we now have Power-assert, and other assertion libraries are available. This episode is already too long, so I'm going to kick the can of that discussion down the road to another episode. If you'd like to see it when it comes out, then please subscribe to the channel. If you click the like button, you'll find it easier to come back to this video when you need it. And if you want to help fund these videos, then you can buy a copy of the book that I wrote with that price called Java to Kotlin and Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.